Welcome back. Okay, so we're going to talk about number 10, part A. I must admit, I sort of feel a little defeated on this problem because I've decided that there's no way I'm going to be able to do it and record it and do it right without making a ton of mistakes. So I'm going to just walk you through it. I've written the solution out so you can understand it. Um, but yes. So what the problem says is we're going to have the same Laplace transform that we had in number 9, okay? We're going to take just one window of it, and we're going to say that we can express it this way for that window, okay? All right, sounds reasonable enough. And we're going to use this finite geometric series, okay? So they write it like this, but that's the same as this. No worries there. Okay. I don't need this detour. Okay, but I just want to sort of think about this. So if we take, and we want to take our g of t, and we want to look at it just in a window, what we're basically doing is we're saying multiply our function by a window, right? And our window function, remember, is the step function of the smaller side minus the step function of the larger side. Okay. So now we're taking our solution from number 9. Let me move this up. We're taking our solution from number 9. Okay, so that was this infinite geometric series, okay, with the window functions t minus kt. Okay, so I'm going to write this. I'm going to multiply each one of these by the appropriate window function. And it's the window function from nt to n plus 1t. So this is the window function, nt to n plus 1t. Same here. Okay, and we're just going to keep going. I could keep going forever and ever. Okay, so I got to figure out what's going on when I take u of t minus t times a window function. All right, let's go to the next page. Okay, so I'm just writing this out. Okay, this is just the same thing that I had there. Let me write the other term that I had, or at least copy it. Okay. Okay, now I want to see what happens. I'm going to talk about what happens when you multiply two step functions together. It's not actually too crazy. If I take u of t minus kt times u of t minus nt, and let's just take k being less than n, then we're really actually going to be left with just the larger one. Okay. Why? What happens? Let's just think about this. So let's say here is kt. So our step function u of kt starts like there, right? Okay, and then the other one doesn't give us an impulse until n t. But it multiplies on there. So when you multiply on there, this little piece just gets multiplied to 0. Okay, so we're left with just the larger piece. Okay, so now we're going to take, yes, you got that, right? Okay. So next, you're going to take, and let's take a look at what happens in 3 cases here, multiplying a step function by a window function. Okay, so now if k is less than n, so that means if k is less than n, then it's also less than n plus 1, right? So that means, remember, your step functions, when you multiply them together, you're going to be left with the larger one. So that means you're going to be left with the larger one here. Okay, so you still get a window function. Okay, let's take a look at n, k equals n. Well, when k equals n, then you're going to be left with the same step function. So that one's fine. This one, n plus 1, is still larger than k. All right, so you're going to be left with this. But now let's take a look at k bigger than n. Okay, now k could be equal to n plus 1. That's still not a problem. But when you multiply k, so when you multiply the step function at k being larger than n, you're going to get the step function at k. Same thing with n plus 1, because the next number, k and n are both integers. So this is going to cancel out to 0. So now, when you're between nt and n plus 1t, you're going to be left with a finite sum. Okay, you're going to be left with a finite sum, not an infinite sum. Okay, we're going to go ahead and pull out the e to the negative alpha t. Okay, when we do that, that one's 1. We get e to the alpha t, e to the 2 alpha t, all the way up to e to the n alpha t, or alpha nt. That's a finite series. And now we can use our geometric series formula, our finite one. Make this a little smaller, just to give you the punchline. Okay, so punchline is, let me not screw this up, pi of nt n plus 1t e to the negative alpha t, that's lowercase t, and that's going to be e to the alpha n plus 1 capital T minus e to the, or minus 1 over e to the alpha t minus 1. Okay, and that's what we wanted. Okay, all right, that's number 10A. I'm not going to do B, that's 10B and 10C. They're not much, but the 10A was the hard one. Okay, all right, I'll see you in the next video.